timeline where we are talking about sustainable farming practices, sustainable energy efficiency, and water conservation. Today we are in Kisumu County, Kisumu East Sub-County, in Nyalenda A Ward, where we are meeting this amazing youth group. This youth group are working recycling domestic wastewater for agriculture farming. We're going to show you today on how the system is using membrane bioreactor (MBR) to help in recycling domestic water. Please subscribe, stay tuned, share the link with your network, and don't forget to leave for us a comment.
My name is Vincent Uduol from Victoria Horticulture Youth Group, based at Lissin Aqua in Nyalenda. So today I want to take you through MBR water treatment process through membrane bioreactor that is commonly known as MBR. So I think we can begin. The first process in wastewater treatment begins at this point where we have the domestic waste being deposited, where we have, first of all, we have the main sewer line coming in from domestic households in town and various estates. Then we have the exhauster trucks as well that brings the waste here. Then from the first pond where it's being collected, we have our pump set up at that point. It's a submersible pump, sewage pump, that collects the wastewater, moves it up to our intake tank that's located inside, that we'll be seeing in a moment. So, okay, from the wastewater lagoon, we pump the small amount that we need, about that's about 3 cubic meters per pumping session, because we pump twice a day, total of 6 cubic meters. So, like right now, we're pumping into this intake tank where we have the raw sewage being stored, and in this tank we have a level sensor and another pump. So the level sensor in this tank helps us control the level at all times to prevent any overflow from the intake tank. So, and the pump, now that's what we use to move this wastewater to the MBR. Our membrane bioreactor room is also abbreviated as MBR. Okay, so welcome to the membrane bioreactor room. So we have this facility. What basically it does is both biological and mechanical filtration. That's through biological. We have an aerobic and aerobic filtration. Then at the far end we have membranes that we filter using this pump. So the whole process takes place on this other side. Maybe we can do what happens is, at this point, this is where the raw sewage from the intake shaft comes in, then moves into this chamber where that we call the pre-filter. Now the pre-filter has a sieve mesh that traps all the solid waste, that is the sand and paper waste. They get trapped at this point, and once it gets filtered out, we get an alarm on the other side to clean it, then put it back for the system to complete. The pre-filter, this is what the pre-filter looks like. We have a mesh like this inside the pre-filter. So anything bigger than the pore size of this pre-filter won't get through. So once it clogs, it fills up, we remove it, put a new one, clean the other one. So we replace them. Yeah? This is where it gets in. And we have a key. So if you want to open this, there's a key for opening it. This one, you just put it in like this. Then open it by just rotating. Once you open it, you take out, there's a mesh like this inside that you take out, put in a new one, then take the other one, clean it, disinfect, then store it for next use. Yeah. Now from this point it moves to the middle section where we have the delignification that's happening, and in between them there's an overflow chamber that transfer that anaerobically treated the water to this other side where we aerate it with this pump. We call it the aeration pump. We add oxygen in it for aerobic filtration. Then at that point, after that, we have this pump, the small circulation pump. We call it the circulation pump that transports that water to the far end on this other side over here. So there we have a membrane. Maybe we just get over to the other side to see how it looks like. The membranes that are attached to those double pumps, we call it the permeate pumps, to suck up that water, the clean water now, to be transported to the outside tank, the permeate. So from that point, we have the UV lamp at the far end that we use to reduce the bacterial load before the water moves to the other side where the fish are for production. And on this other side also we have this other blower. We call it the scouring blower. This helps us to control clogging of those membranes. Yeah. So the membranes, maybe you can move closer to this other side to see the membranes that we have. So at the mechanical filtration section, we have the membranes that are attached to the permeate pumps, and each of them filter that water out to the permeate tank. So what the membranes look like, this is a slit one, just a piece to show you what it looks like. This is what the membrane looks like. So the pump is attached to this other side, where that sucks water through this white surface that you see here. That's what we call the membrane. So we have several of them attached to one. There's a membrane block over here. You can see one, the complete one. This is now a full membrane, single one that is preserved. You can see water. This one has a bit of water that it has sucked in. So if you attach a pump to this other side, it will pump it out. Clean water. And on this other end we have for the whole system. So now on the control panel there's different settings where we have home, inlet, the MBR itself to see what happens in the other side. So now with the home panel, this is just the flow overview of what's happening from the field tank. Like right now it's showing us it's at 89%. If it gets to 100%, that's when we need to shut down the pump. Then notification pump, that's now inside the tank, what it looks like, and all that to the end. The filter flow of each of these pumps, the permeate pumps. That's pump 1 and pump 2 on the other end. Now in the inlet, now this one is specifically dedicated to the field tank, where we can see there's a diagram of the field tank itself and the percentage water level and the working condition of the pump as well, that's inside there. So if there's any fault, they will get a notification over there, and the lighting, a blinking light as well, to notify us of any fault at that point. Then this other end we have the MBR now, schematic flow, drawing of what the system looks like, the 3 chambers, the identification chamber, nitrification, and also the filtration chamber, what they look like. And also with the pumps, their flow rates and everything, including the blowers. Now over here, these are control buttons that we have. Right now, they have 3 control options. We have the manual option, off, and automatic. Right now, all of them are in automatic mode except one, the sludge pump, because right now we don't have a sludge, so we keep it on close because we don't want it also pumping out sludge at night when we are not around, because it will affect our the amount of water that we'll get during in the morning. So we keep it in off position, and when we get an alarm, like right now, it's when we put it on automatic mode to discharge the sludge to deal with the alarm when we are around. Yeah. From the permeate tank, we have a pump that pumps it all the way to this other side, passes through the UV lamp, out to the other side, now to the fish section. So any bacteria that pass through the system, this is where we deal with it. Maybe on this other side, now can get up. Now this is where we have a control panel where we measure real time Now, this panel, this is where we measure real-time water quality parameters from dissolved oxygen in each of the tanks to we have redox as well as pH. So this one provides us with all those real-time information from the time this system started to date. Every time we get that data, and it's stored within the system, and it can be downloaded anytime, whenever needed. These are just backup batteries that control that system because it needs to be operational throughout. So these are backup power units for this control unit. Yeah. And maybe we can just get up to appreciate what's happening inside. This point, this is where we have the denitrification tank. Then this is the overflow chamber that I mentioned. It gets to this other side where we have the aeration. You can see the bubbling and all that happening here. To provide enough oxygen for aerobic respiration. Then the circulation pump is the other one, bringing water to the other end where we have the membranes. The membranes right now they are totally covered. That's how they should be covered completely by the water, the wastewater, to be able to work efficiently. So from all the waste that you've seen inside there, this is the end product, filtered water now that you get. Now this is the permeate. So after getting this, we pass it through UV lamp now. And the water is odorless, clear, and very low in bacterial load. And it's good for agriculture and aquaculture. It's still not recommended for drinking though, but can be used for other household items like laundry and flushing of toilets and all sorts of other use. Now this is the permeate tank, the white tank where we collect all the permeate. So this tank, these are 2,000 liter tanks that get filled twice every day. Provide us with the water that we use inside there for fish and also for irrigation in the farm. Yes.
Okay, now we have MBR treated water with the municipal treated water. From the two, you can note the difference by yourselves. Out of the two samples, from the MBR treated water with the municipal waste treated water, the difference speaks for itself, at least for the viewers. They have a chance now to see which one they can believe in more.
Thanks so much for watching this episode. I hope you've learned something. Don't waste your wastewater. Learn from this system and recycle your wastewater and use it sustainably to increase your household income while fighting climate change. Thanks so much.